For this video, we're going to be discussing radical equations. So a radical equation is obviously just an equation that has a radical in it. So let's talk about some steps to solve one. Step one is going to be to isolate the radical. You want to get the radical part of the equation by itself on one side. The second part will be to raise each side of the equation to the index of the radical. That gets rid of the radical. Step three is to solve whatever equation you have left. And then step four is to check your answers for extraneous solutions. What that means is the process in which we solve a radical equation is sometimes going to give us answers that don't actually work for the original equation, and we have to check to make sure our answers work. So this step, step four, is actually really important. Like checking your work is a big deal when it comes to solving a radical equation. So let's just look at some examples. So I want to solve 9 plus the square root of 1 minus 12x equals 16. So step one is to isolate the radical. I want to get this radical by itself. So I got to get rid of this 9. So first thing I'm going to do, just subtract 9 on both sides. So I've got square root of 1 minus 12x equals 16 minus 9, which is 7. All right, so now that I've isolated this, my next step is to raise both sides to the index of my radical. Now remember, if it's a square root, my index is just 2, even though it's not written there. So what am I going to do? I'm going to square both sides of my expression, or my equation. Squaring this side makes the radical just go away, so I've got 1 minus 12x, and on the other side, 7 squared, that gets me 49. Now I've just got a two-step equation to solve, so I'm going to subtract 1 on both sides. So I've got negative 12x equals 48. I'm going to divide both sides by negative 12. And if I divide both sides by negative 12, I get an answer of x equals negative 4. So that's the process for solving. Okay, get your radical by itself, raise both sides to the index of your radical, and then solve the equation that you have left. Now it's really important that I check my answer to make sure that negative 4 works in my original expression. So I'm just going to take negative 4, and to check it, I'm going to plug it back into the original expression. All right, so if I now work this out just using order of operations, okay, if I multiply negative 12 times negative 4, I get positive 48. Then if I go, all right, 1 plus 48 is 49, so I've got 9 plus the square root of 49 equals 16. Square root of 49 is 7. And 9 plus 7 is 16. I got the same thing on both sides, and that's what I want to happen. This checks out, so my answer of negative 4 works, and that is the correct answer to this problem. All right, let's take a look at another example. So in this one, I've got the square root of 2 minus x equals x minus 2. All right, so to work this one out, I don't need to isolate my radical. It's already by itself. So I'm going to start, okay, I'm going to start by simply squaring both sides to get rid of my my radical over here. So on this side, square root of 2 minus x squared is just 2 minus x. On the other side, x minus 2 squared, hopefully you remember, is x minus 2 times x minus 2. X times x, negative 2 times x times negative 2, negative 2 times negative 2. I've got to do my distributive property twice. X times x is x squared. Negative 2 times x is negative 2x. X times negative 2 is negative 2x. And negative 2 times negative 2 is positive 4. So this side ends up being x squared minus 2x plus 4. All right, which I can combine like terms to have x squared minus 4x plus 4. I've got a quadratic equation now. So I need to get one side equal to 0. I'm going to do that by subtracting 2 on both sides and adding x on both sides. All right, and if I do that, I end up with 0 equals x squared minus 3x plus 2. All right, so now I'm going to use quadratic formula to solve this problem. So if I plug the numbers from this problem into the quadratic formula, I've got 1 is my a, negative 3 is my b value, and 2 is my c value. So I'm going to plug those in. Looks like this. If I work that out, that becomes 3. Underneath my radical, 3 squared is 9. 4 times 1 times 2 is 8. 9 minus 8 is 1. So I get 3 plus or minus the square root of 1 over 2. Square root of 1 is just 1. So if I continue this out, 3 plus 1 is 4, divided by 2 is 2. 3 minus 1 is 2, divided by 2 is 1. So I get two answers of 2 and 1. Now I've got to check both of these answers to make sure they work. So I'm just going to take them both and plug them in to my original equation. So I'm going to take 2 and plug it in wherever I see an x in my original equation. So I've got square root of 2 minus 2 equals 2 minus 2. 2 minus 2 is 0, so I've got the square root of 0 equals 0. The square root of 0 is 0. So that checks out. So I know 2 works as an answer. Now I need to check 1. So I'm going to do the square root of 1 minus 2 equals 1 minus 2. Well, 1 minus 2 is negative 1, and on this side I get 1 minus 2, which that says 1, but it should say negative 1. But we know the square root of negative 1 is I, and I, this side should be negative 1. I does not equal negative 1. Because these two sides are not exactly the same, that means that this is what we call an extraneous solution, and it doesn't work. It doesn't count. Okay, so our only answer to this problem is 2. All right, so I'm going to leave you with a try it problem. I want you to solve the fourth root of 2p plus 2 equals 3. All right, so remember the steps. Isolate your radical, raise both sides to the index, solve your resulting equation, and then check your answer by plugging it back into your original equation.